Today we will speak about development of signal control priority application in connected vehicles environment using Vissim. And generally today, and connected vehicles are relatively new technologies and still in the deployment phase. Even though these technologies can have great potential to improve safety, mobility, and operations, number of field tests is very limited, so we need more simulation models. CB technologies enable safe communication between vehicle to vehicle, vehicle to infrastructure, vehicle to device, or vice versa. And currently, US DOT has several ongoing programs to develop CV-based applications. Using only vehicle to infrastructure communications is already available about 50 applications to reduce crashes, decrease travel times, reduce emissions and fuel consumptions. Our research is focused on four CV applications: intelligent traffic signal systems, queue warning, dynamic speed harmonization, signal control priority. Today we will speak a little bit more about signal control priority. And many fields and simulations studies showed that efficiency and benefit of transit signal priority or freight signal priority has efficiency and benefits, but at the same time some negative effects on another vehicle traffic or side streets. And functionality of the control priorities, control signal priority directly depend on the communication between vehicle and the controller. So far, this communication was achieved through traditional detectors or later GPS, and all of these technologies can actually ensure activation of the TSP, but also has some kind of weaknesses. And from that point, connected vehicles actually can improve that systems, providing very accurate, detailed information which can be transmitted 10 times per second, and also can provide some kind of flexibility when and how that information will be transmitted. To be sure that that one signal control priority application works, vehicles need to have onboard equipment installed already, and controllers need to have roadside units. Between these two units, it's necessary to do transmission of the basic safety messages, and information that are contained in basic safety messages can be different, depend of the purpose. In case of the signal control priority, vehicles will send signal request message, while controller will answer with signal status message. To be sure, actually to create one successful signal control priority application in a CV environment, and including transmission of the basic safety message and rules for signal control priority activation in Vissim microsimulation models, it is necessary to combine several tools. It's traffic controller, software in the loop, component object model, known as COM functions, as well some settings directly in the Vissim. Here we will start directly with settings in the Vissim, and it is related to user-defined attributes. Using some already provided PTV's examples, all Vissim coordinates are converted to world coordinates. So it means that during simulation, each vehicle with onboard equipment is able to broadcast actual latitude and longitude coordinates to the controller. Another step is actually settings directly in the controller. Our examples are based on external Econate controller ASC3, and for each intersections is necessary to have separate controller and separate settings. And here actually will be finished settings for control operations, priority, and control logics. Once when we define how many logics we need, what is this first step, we should define as well how many, which phase or phases will accommodate that logic, and as well which kind of treatment that priority will have. Is that green extensions, earlier green, or maybe phase rotations? And this is necessary for each logic. And as well, we need to enable each of that logics. In our examples, we have 12 of them. And for each of them is also conducted separate settings for each of these 12 separate logic commands. Once when we have created that and we have simulation, it is possible to do or actually to check signal control priority status following the options from the main menu. We can see is that signal control priority activate or not. After all these settings related to Vissim and controller, it comes to set communication between vehicle and the controller. As this part is actually programmed directly in a Python script, and all options that are used are pulled out from the COM functions. Here is visible that we use some detectors, and in this case, actually, detectors are used to mimic roadside units that will receive requests for priority and will forward that information to the controller logics that are already programmed, as we saw in the previous slides. Well, after that, we need to also define some separate kind of the vehicles. Here we have two examples. One example is related to freight signal priority, and we have two types of the vehicle, or actually of the trucks. It is 101 and 102. Difference between them is that one of them are inside of the range of the detection, while other are out of the range of the detection. In this, another example is for the transit vehicles and the same approach. And now we have actually open question, what is appropriate range of the detection for the signal control priority? Actually, that depends on the information that will be contained in the basic safety message. And one of the main information that have to be contained there is actually distance between vehicle and the traffic controller. Since that we're speaking about connected vehicles, that distance will be updated in each time step, and it's calculated using Harrison formula. And here also we have an example from the Python script how we did that. And with option that we can update distance with each time step, and that is one of the basic information and basic safety message. We have open options to calculate some other parameters, like time that vehicle need to reach one intersections. And here we have example where we used exactly time as one of parameter in basic safety message combined with the queue conditions. We actually have option to define which kind of information will be contained, and that we define which conditions actually will be necessary to grant priority for the one vehicle. Another example is a little bit more complex than this previous, but actually it shows us that number of conditions can be extended. So we here have, besides the expected arrival time, we also have the number of passengers on the board on the bus and adherence to the schedule. So if case that we have a vehicle that is a little bit late, or maybe that's going behind the schedule or something. Using these three conditions can lead us to also to provide conditional priority and priority levels. So depending of the combination of these conditions, in the end we can end up with maybe with low priority or high priority. In the end, all these treatments will they will get different treatments. For example, low priority will get green extensions on earlier green, while high priority will be additionally aid with phase rotation. And all these functions are possible to be done through Python scripts included in simulation. Once when we get all that results, we need to do evaluation of all of them. And good things that that procedure is actually the same as when we have a model without connected vehicles. So all that vehicles that we already programmed through Python scripts are available in our reports through vehicle network performance or node results or any other. So that procedure is actually very simple in the end. Thank you, and if you have any questions, we are happy to answer.
So if you let me just add a couple of things that we actually want to emphasize with this research. So one is first, if you look closely, we actually moved away from using links in Vissim to determine the distance between the vehicle and the intersection. And we used the vehicle's lat and long coordinates to do that. And that gave us a lot more freedom of how to define the detection zone. And then the second one is where the magic actually happens is in that logic processor that we use in the ASC3 software in the loop. So for every intersection, we have probably like a dozen or so additional virtual detectors. And then based on the conditions that Zorica was showing you, the like no priority, low priority, high priority. So based on those conditions, we would actually activate a certain detector, and then that detector would call the logic inside the controller, and then we would be able to, for example, do just green extension or do green extension or early green in combination, or also employ the phase rotation as well. So these are a couple of things that we kind of try to add a little bit different than something that were done so far. So again, if you guys have any questions, we can go ahead and open up a discussion.
All right. Yes. Thank you both for the presentation, and I'll look through here. I think I have something to check on for a question or an input anyway. All right. Well, I'm being told from our team to mention that I can mention that in Vissim 2021, the lat long are default attributes for vehicles and other objects. So I'll pass that along during this. I don't see questions in the question box currently for you guys. But you were using, yeah, okay, sorry. I guess I'll just wait a second or offer up to you guys any other thoughts that you wanted to add.
Yeah, we started this project before 2021 came out, so it was older Vissim version, so we had to find a workaround how to do this. But
gotcha. Yeah, totally.
It's a good thing to have something that makes things easier in the new versions.